We have over the next 45 minutes, we're going to talk about stakeholder needs and communication, and that is a very broad topic with a lot of different pieces. I think traditionally search has considered stakeholders, for example, among the list of partners. I think the list from HioICAN that Cecilia showed earlier. And this includes Arctic residents, Arctic industrial and commercial enterprises, transportation, NGOs, people who are very closely, directly invested in Arctic activities one way or another. Toward the end of the talk today, I'll be talking a bit about a very much broader view, which is the general public as stakeholders, what they know and believe and care about the Arctic, and perhaps with some connections to how we communicate better with them. Both of those are parts of the SIPN, the Sea Ice Prediction Network's planned activities. And is Helen here? She'll be back. Okay, I'll ask her to say a bit about there you are. Okay, I was just taking your name in vain. Okay, maybe Helen will say just a few words about the activities we have planned as far as surveying and contacting stakeholders about their information needs. Yeah, can we get a microphone to her? No.
Okay, thanks, Larry. So we'll probably be focusing on sort of three groups of stakeholders. So one of the challenges is defining them, because we can't respond to everybody's needs. Scientists are definitely a group of stakeholders. So I'm really interested in what you guys need as far as coordination, communication, meetings, webinars, workshops. Sorry, I ran up here. The engaged public, which Larry will talk about, and then coastal communities and industry. So that's something that we're talking with a group of stakeholders about, that, what they need, and sort of how to reconcile their needs with what the sea ice prediction community can provide, which is not always easy. So we'll be working on that in the next few months. Okay,
thank you. And so that's one set of activities, contacting stakeholders about their needs and interests. I'll talk about the general public aspect later in the session, but there's something new under the sun, and we have a guest contributor by telephone from Europe. We hope this experiment works, known by the name of Neven. He is the originator and brains behind the Arctic Sea Ice blog, which is something, in my view, something new under the sun, and a fascinating place where you see a collection mainly of citizen scientists who are very close watchers and consumers, and in many cases actually original analysts of Arctic sea ice and other relevant data sets. And I hope we can have Neven here to tell us a bit about the Sea Ice blog and contribute any observations, any thoughts he might have relevant to this meeting. I understand we have him online now.
Yes.
Okay, Neven, I've got your, I don't know if you can, are you able to get visual of this?
Yes, I see you, Larry.
Okay, very good. I've got your PowerPoint here, and I can also run the Sea Ice blog if you'd like that. So just tell me when to hit the switch.
Okay, great. So I'll just start then?
Yes, go ahead.
There's a bit of a delay, so I switched off some of the volume of the hearing. I want to thank you, Larry, and I'd also like to thank the workshop organizers for inviting me to give this short presentation on Arctic sea ice, public perception, and citizen science. When I was asked 2 weeks ago, I thought this would be an April Fool's joke, but it seems real enough. So that's great. Okay, so who am I? My name is Neven. I'm a 39 years old Dutchman, currently living in Austria with my wife and daughter. In real life, I work as a translator, and in my spare time, I write for the Arctic Sea Ice blog. And as you might have guessed, this blog is about Arctic sea ice. The blog is very active during the melting season with reports every week or 2 weeks on the way the melting season is proceeding and other news and analysis. I don't know if all of you know the Arctic Sea Ice blog. Maybe you can put up your hand if you do. Don't worry, I can't see you.
It's about 2/3.
Okay. Oh, that's great. So next slide, please, Larry. The next slide. Yeah, thanks.
Yes. Oh, yes, we have it.
Yeah, great. That's the blog. So as said, given the recent and rapid changes in the Arctic, the stakeholder community is becoming larger and more diverse, mostly because of an increase in attention from the general public. And the Arctic Sea Ice blog is a direct consequence and evidence of this, as I will show later. The blog was created by me in the summer of 2010 for the following reasons. Just like the Search Sea Ice Outlook was kicked off after the dramatic 2007 melting season, interest in Arctic sea ice increased a lot on the internet. But the discussions took place in different little corners every year, every melting season, and I was kind of like missing a central place for more focused discussion. The Arctic and its sea ice are fascinating subjects, and I'm also a sucker for looking at graphs, and so I was quickly grabbed by the way and the speed with which sea ice decreased during melting seasons. So basically my thought was that the Arctic sea ice deserved a blog of its own. Next slide, please.
Okay.
My other reason for starting the blog was that I've been interested in global warming and climate change for many years. And frankly, I was, and still am, hold on. Oh, my computer just crashed.
No.
Yeah, so I don't have all my pointers now. I'll try to do it, I'll just try to continue because it's going to take 10 minutes for my computer to restart. Basically, my screen has, I don't have any visuals anymore. So I was saying, oh yeah, okay, so I was worried about, still am worried about global warming and climate change. And as Arctic sea ice is at the forefront of what is happening, I thought that, well, this is not working. I'm sorry. Can you guys give me a few minutes to start everything up again?
Sure, we can. I can talk a bit about the surveys. What you think, about 10 minutes?
Okay, yeah, please. I'm really sorry about this. I've been sitting and watching you for 2 hours, and everything is going great. And that's what's that guy called, Murphy? Yeah.
Yes.
Okay, I'll be back in 10 minutes.
Okay, we very much want to hear what you have to say, Nevin. Thanks.
Thanks.
Okay, so in the show must go on tradition, see if I can let's see, the earlier, yeah, where did we just erase the, okay, where's the survey presentation? Ah, there we go, Larry survey. Yeah. Okay, something completely different while we're waiting for Nevin to restart his computer. I mentioned that I was going to be doing this anyway, so I'm just pulled it ahead 10 minutes. I've been doing putting questions about the Arctic on random sample telephone interview public surveys for a number of years, and part of the idea is to find out what people know, what they believe, and also to watch and see how that changes. But it's more detailed because there's a lot of analysis about who believes what or who knows what. Where did they get that information? And as part of this effort, there have been a series of questions, standardized questions that we've been placing on a wide range of regional, a few national, and in particularly New Hampshire statewide surveys since 2010. I'll start off really quickly with one about climate change. It's very general. And which of the following 3 statements do you personally believe? That climate change is happening now, caused mainly by human activities, that climate change is happening now but caused mainly by natural forces, or that climate change is not happening now. And this was designed so that the first choice corresponds to the consensus statements by all major science organizations. But of course, it's not identified as such in the survey. And results at the top, you see results to that question from 3 different surveys: a national survey called the General Social Survey, national survey called NSERA, and a collection of New Hampshire statewide surveys, very similar, 53, 52, 54%, accepting anthropogenic climate change. At the bottom panel, you see the results from a bunch of regional surveys. If you go into regions, there's a lot of place-to-place variation, but New Hampshire's not far off the national level. And it's been boringly constant over the last 4 years. The top line is the percent saying now human on New Hampshire statewide surveys about every 3 months since April of 2010. And you see a couple of little TIE fighters there that are indicate the 2 national surveys, which are pretty much right on, but right within the confidence intervals in the New Hampshire surveys. If you break it down by political party, all of these different surveys agree that there's that really what's anchoring the whole thing is very stable political convictions that aren't much affected by scientific developments. So I just set that up as the idea that New Hampshire is an interesting proxy, and it's very cost effective as a way of tracking these things in real time. We have another question, more Arctic focused. If the Arctic region becomes warmer in the future, do you think that will have no effects, minor effects, or major effects on the weather where you live? And 60% of our New Hampshire respondents said they thought it would have major effects, which is a lot more than I thought, and about 89% think it will have at least minor effects. So there's a wide acceptance. Kind of an interesting finding of this was that it correlates with temperature on the day you were asked that question in a curvilinear way. So that if it's an unseasonably cool or warm day when you're asked that question, you're more likely to think that Arctic warming will affect your weather. And this is controlling for age and education and political party and various other things. There's a paper we had about this last fall. Another Arctic question is, which of the following 3 statements do you think is more accurate? Over the past few years, ice on the Arctic Ocean in late summer covers less area than it did 30 years ago, declined but then recovered to about the same area it had 30 years ago, or covers more area than it did 30 years ago. I try to write survey questions that are not dumbed down, that have a real clear, definitive answer. You could write a much dumber question than that and still get very similar survey responses, because people will parse it in an imprecise way. But in terms of an interface to the scientific community, it seems better to have this question phrased in the terms that they would recognize. Anyway, 71% recognize that Arctic sea ice area is less than it was 30 years ago in late summer. And what we're doing with that is we're beginning the time series. Okay, Nevin is back, and this is the last slide, so the timing is fortuitous. We're beginning a time series. We're following this now. The blue line here are 4 successive surveys in which we asked the Arctic sea ice question. You'll notice it was going along kind of level until it really dipped last fall. So people heard that Arctic ice was up last fall. Now, it was not up to the level of 30 years ago, but nevertheless, that filtered into the public imagination as the idea that sea ice had recovered. And then the lower one has to do with the Arctic weather question. There's only one small, non-significant blip there that happens to be the survey after Hurricane Sandy swept through the Northeast. So anyway, we're continuing these surveys, and we'll continue to do them, and it's very interesting stuff. There are about 4 papers published on this over the last few years, and I'd be happy to send anybody reprints of those if they want. And so I think now hopefully we have Nevin back. Is that the case?
I'm here, yeah.
All right, let me find your slide again and...
Okay, while you do that, I apologize for this, for the crash. I've turned everything off on my computer, the lights, I've shut all the windows, so hopefully things work out now.
Okay. Yes, I'm not...
We're at slide number 2.
All right, I think we are back at slide number 2. Please go ahead.
Great. So I was talking about the reasons for me starting the Arctic Sea Ice blog. And the second reason I started it because I was worried about global warming. And I thought that maybe by calling attention to what is happening in the Arctic, my hope is that the debate will shift faster from the question, is it real, to what do we do about it? You know, I'm a scientist, I can do that, and I'm upfront about this motivation, and at the same time I try not to get overexcited or too alarmist. You know, I also want to be a little bit credible, and fortunately, or perhaps unfortunately, there's no need to exaggerate. I can just report as is. Next slide, please.
Okay.
So I started writing in 2010, mainly describing the things I wondered about and what I learned along the way. And right from the start, people started flocking to the blog. It was a bit like Alcoholics Anonymous, you know, where people go like, oh, finally a place where I can talk about this and ask what other people think. Well, at least it was for me like that. So that was great. You know, the exchange of knowledge was what the blog was all about. And people started to interpret the data and speculate about what was going on below the satellite sensors and forecast what would happen in the short and longer term. And now there was one guy who had assembled a couple of graphs on a Google site. It's a free website that gave a quick overview of conditions in the Arctic. And so I decided to copy that, and that's how the Arctic sea ice graphs page came about. Next slide, please.
Okay.
Currently, there's the daily graphs page that shows practically all daily updated graphs and maps that are available online and have something to do with Arctic sea ice extent or area or air, sea surface temperature, sea level pressure, etc. There's one page with regional extent and area graphs. There's a long-term graphs page that shows the historic trends. There's a page where concentration maps for the last 8 years can be compared quickly, so you can see if something is new or if it happened before in the last 8 years. And there's a similar page for sea level pressure patterns. And finally, there's a page with live webcams, like the North Pole webcam that is quite popular during summer. So in the meantime, the blog became more and more popular every melting season, to the point where the comment sections got a bit messy, in the sense that people wouldn't stick to the topic at hand and started discussing all kinds of related and unrelated subjects. And so instead of moderating heavily or whining all the time to everyone to stop, I decided to create a place for all the off-topic stuff. And so with the help of one of the community members, I set up the Arctic Sea Ice Forum. Next slide, please.
Okay.
Yeah, here at the forum, people can basically discuss whatever they like, or almost. And the good thing is that now all the interesting stuff and discussions are concentrated in separate threads, which is very handy and also a good source for me for writing for the blog. And it also makes it easier for people to contribute. So there are a couple of amateur weather experts. There's a guy writing extensively about Antarctic sea ice. Someone is keeping a watch on Greenland glaciers. Someone else is offering daily updated statistics on sea ice extent and area. People are posting animations, maps, graphs, you name it, and of course a lot of people are reading all of that. And I want to show a couple of examples of the things that have come out of this community of citizen scientists in the past 4 years. Some of these things have spread beyond the blog and even the internet, getting into the media. And maybe you'll get inspired or see things you can use for your own presentations. So the next slide, please.
Okay.
On the top left, for instance, is the sea ice area graph that shows where the current trend line will go if it follows previous years or time periods. Next to that, to the right, is a bar graph made by Larry Hamilton, and it shows the historic sea ice extent trend. On the bottom left is a graph made by a fellow Dutchman called Witneus. He's a very prolific commenter who makes all kinds of very useful animations and graphs. And this graph shows expected trends for biomass sea ice volume using different statistical techniques. because people want to know when the Arctic will be ice-free, and using the different techniques you get an idea. Next to that is the KP graph that was made by me, where I divide area by extent, which gives a crude idea of sea ice compactness, and also about the amount of melt bonding during the first half of the melting season. So I regularly use that for my 2-week analysis during the melting season. Next slide, please.
Okay.
These are 4 of the many animations made by the Arctic Sea Ice Blog community. Unfortunately, they're not moving, they're static, but I'm sure you get the gist. On the top left is an animation made by a commenter called A-Team that made the rounds on the internet last year during the spectacular cracking event in the Beaufort Sea that you will probably remember. Next to it is a very sleek-looking YouTube video made by programmer Andy Lee Robinson that visualizes Arctic sea ice volume loss. So that has about 80,000 views on YouTube, I believe, and even appeared on some television news programs. On the bottom left is another animation that is made by the aforementioned Witness. He uses AMSR2 data to make his own sea ice concentration maps with a very high resolution, I believe the highest resolution available, though it's still under construction, I believe, at the University of Hamburg. And by posting animation, he shows changes going on in different regions. And next to that is an example of the animation I make every year of the ice arch breakup in Nares Strait. And for that I use Lance Modis satellite images, which are awesome. Okay, so now I want to talk about the reach of the Arctic Sea Ice Blog, the forum and the graphs page. And for that I'll need the next slide.
Okay.
So, of course, things haven't quite reached the level of attention that is garnered by blogs about Justin Bieber or Russian dash cams or cute domestic animals. Yeah, but for a climate blog that is about one subject only, it's above average and still growing. In fact, the number of visitors and page views correlate very strongly with Arctic sea ice melt. So when there's a lot of melt, the blog is very busy. When not much is going on, the numbers drop. So I'll be publishing a paper on this correlation soon in Not So Physical Research Letters. That was a joke. But seriously, in a little under 4 years, the blog has attracted 1.5 million unique visitors, producing around 4.5 million page views. And the forum has had almost as many page views in just 1 year, but that's because a forum is much more interactive. The forum currently has almost 600 members. The Arctic Sea Ice Graphs page has had over 1 million page views so far. So these numbers make clear that there's a growing interest in Arctic sea ice loss. And this is, of course, also reflected in the media. And, well, I've been asked to comment a bit about the way you guys, the scientists, communicate with the public and how this can be improved. And so what does this all mean for the scientific community? Yeah? What is asked of you? So next slide, please.
Okay.
Okay, well, this is my last joke. So that is just I wanted to do Uncle Sam, but I thought this one was even funnier. So much is being said about communication of science with the public. And, well, I'm not really qualified, and there's not really that much that I can add to it. Personally, I'm not asking anything in particular of scientists studying Arctic sea ice with regards to their communication. I think that, in general, they're doing a really good job. But, well, sea ice, of course, is a hot subject, and it can make people lose their cool. And, you know, where people tend to exaggerate and everything and get a bit too alarmist. And when that happens, I think it's fine to react conservatively or with so-called reticence, because that's what's expected of scientists. But at the same time, in my opinion, this reticence must be balanced by stressing the risks involved with Arctic sea ice loss, especially given the rate with which it has been happening so far, and all of the uncertainty involved with regards to the future. I mean, this workshop is all about how difficult forecasting is. So reticence and stressing the risks don't bite each other. It's not an either-or proposition, especially as the media and public attention will shift from Arctic sea ice loss itself to the consequences of this loss as it continues, which it very likely will. So more will probably be asked of you, and I hope to see more of you commenting publicly as scientists in years to come, because I think you can play a very positive role either way. So I'd like to close off with some remarks on my personal communication with scientists, which has been great so far, really great. My questions always get answered. I sometimes get useful tips or useful papers. I'm very grateful for that. And if any of you would like to use the blog as an intermediary and write a guest blog about your work or take the opportunity of interacting directly with members of the public, the Arctic Sea Ice blog is at your disposal. Last slide, please.
Okay.
Yeah. I hope, well, that's me with my daughter, but I prefer to stay anonymous, so I thought this would be a good image. I hope this presentation has given you some idea about public perception and citizen science participation. Thank you for listening, and I wish you all an interesting and fruitful workshop, and may your forecasts thrive.
Well, thank you very much, Neven. And you just got an applause. I don't know if you could pick that up or not. And if you can stick around for a few minutes, the audience may have some questions for you. If we're set up to do that. Any questions? While the microphone is running around, I'll just mention Neven ended there with an invitation for for scientists to participate in the blog, and I'll say he has a very open process if you wish to write a guest blog on any topic. I've done that several times, and it's worked very well, and you get a fascinating discussion. You might get 100 responses to something from people who are really thoughtful. It's very different from what you may have encountered on some other blogs out there in the universe. So I would strongly, I would go with Neven's "I want you" slide and say that, yeah, more participation by scientists would be a very welcome thing there, I think. So, questions?
Yeah, hi, Neven. Sorry, thank you. My question is, if there was, say, a 5 or 10 year pause in Arctic sea ice, and that potentially made people less inclined to act on climate change and potentially less believing in the impacts of climate change, how that would make you feel and how you would go about communicating that idea to the public?
Well, like I said, I try to report as is, yes. So if things would slow down, if multi-year ice would start to increase, if volume would go up, then I would report that, and that would be really good news, of course. So I always stress the uncertainty, yeah. Also because I know how little I know about the Arctic, so I try not to be definitive. I stress the risks because I believe they are there, and then what happens happens. If people take notice, great. If people don't take notice, okay, that's fine too, But I just put it out there, it's there, and if people are interested, then that makes it easier to find.
Okay, any other questions? Okay, then it looks like we're wrapping up here then, and I will put up the blog itself and just mention something about one of the things that Neven showed in his last slides. The most recent post, which I believe was yesterday, is in fact about this workshop and mentions the GRL paper that I described earlier. And that's this Forecast Me Not post that Nevin has written. And it already has, it looks like a couple of dozen comments on it. So you get real-time feedback from people who are very interested in the content in the topic area, and often very useful, but also I think this is a very important bridge between scientists and the broader public. Cecilia, who's got the microphone? Okay, we have one more question from Cecilia.
Hi, Nevin. I have a question for you and probably for others in this room, where when I often speak to the public or journalists, I am asked questions that I'm not exactly an expert on. And when you suggest that we talk about risk, I'm not an expert on risk analysis. How do you propose that someone who's very specialized, like us, speaks when asked questions that we don't feel as much an expert on?
Yeah. Well, you say that you're not an expert on that particular question. I mean, that's how I would do it. I always say it when I don't know something. I say I don't know much about this, but if you really want to know my opinion, then I think that there's a lot of uncertainty, and this uncertainty is not our friend. It would be better if we knew more. And given the recent trends, that's all I'm saying about it. So when I say that you have to, or you should stress the risks as a balance to the normal conservatism, I mean that that you should. I don't mean to say that you make policy proposals. Yeah, I don't say that this and this could happen, so this and this should be done. I'm saying I see a scientist in front of me, like people see scientists with a white coat and the pen in the pocket, and really dryly say we don't know what's going to happen, which means that the risks it could be risky. And saying that like, a bit like Dr. Spock or something like that, I just wanted to express that it's not the one or the other. It goes well together. And I think that if you say that there are risks, that doesn't make you less credible or less of an expert. That was my point, which isn't original, by the way.
Okay. Thank you. I would just add one other thing. Since I've got your website up right now, I can interactively, I can pull up, say, the Sea Ice Graphs page, I think, and scroll down it to, well, it'll take a minute to load, but to show more of the graphics. And some of these are done by agencies. You'll see all the familiar ones. But there also are a lot of graphs that are done by people on the Sea Ice blog or for the Sea Ice blog. And in a sense, they are data consumers. They're people who want the numerical data that is being produced by various scientific groups, and then will run in one fashion or another their own analyses of those. And I think this is, again, this is something new under the sun, that you have a group of citizen scientists who have analytical skills, who can use mapping software, who can use statistical software, who can construct animations, and that they want to see the numbers. And as we publish our data in a timely, very accessible format, it's reaching a new audience in real time and sort of empowering that audience to become engaged in the science in a way that I don't think you'd find many analogs for in, certainly not in Arctic research. The best comparison I could suggest is amateur astronomy, where citizen scientists play a very large and creative role. So I think that the Sea Ice blog is just almost by itself an encouragement to publish your data where you can in a public-friendly format. You know, comma delimited text files can be read by anybody anywhere, and it's not very much of a burden, I think, to create files in that format instead of something else. You've still got many legacy files on the internet that are in some strange Fortran formatting with lots of blank spaces and column organization and so forth. Just, you know, be aware of how people, you know, can grab something from the internet and paste it into Excel and then feed it to whatever analytical software they have, and that they're doing that in a very active way. So yeah, this is not loading, so I'm not going to be able to show you what I wanted to here. But there are, you know, this is sort of a go-to place where people have, these are long-term graphs, almost all done by blog contributors, I think, rather than scientific teams. Well, some of them will look familiar, but it's a very interesting place to spend some time browsing around if you haven't done that. And incidentally, they're commenting already on this conference that you know, that the audience needs to hold the microphone like a rock star indeed, and things like that. So new level of engagement. Okay, any other questions or comments for Nevin? Okay, Nevin, any closing remarks?
Well, I was thinking about what you just said about data being available, and you also see with the Sea Ice outlooks that there's more public participation. And I think I'm not one of those because I'm more like a journalist. I'm not much of on a scientific level, not so strong. But yeah, there are some data during the melting season that people would love to get their hands on, of course. Things like melt pond data or ocean heat flux, you know, how much is flowing through Bering Strait or the Fram Strait. And I know a lot of those things are out there, but it would also be nice if you have graphs and maps, more graphs, more maps. That's all I say.
Okay.
So, but thanks. I think there's already so much out there. It's so fascinating. So I want to thank everybody for what is there already. Okay.
Well, thank you very much for participating today. I think you've given us a lot of good information. So, thank you.
Thank you.
Okay. All right. Cecilia reminds me that I made a presentation too, and if anybody would like, that was the survey thing that went by so quickly there. If anyone would like to ask any questions about that, or questions for Helen about the stakeholder engagement plans. No.
Quick question was, so you said people, if it's a warm day, people think there's more warming. If it's a cold day, people don't. In terms of regional, if you live somewhere with a very high annual variance versus a coastal area that doesn't have anything, did you see anything in terms of that? Because if you live in the Arctic and you have a glacier behind you that is retreating, you're going, wow, that's changed. You live on the coast in the tropics, yeah.
Well, that's a really good, that's a key methodological question. The type of work I'm showing you where people are taking survey questionnaire data and then correlating that one way or another with either weather or climate information is a hot topic right now. I review papers about that every month. Lots of different people are trying to do it. It's methodologically tricky for exactly the reason you mentioned there, which is that the day-to-day or longer-term variations in the weather or climate indexes are correlated with geography, but public opinion is correlated with geography too. And so there's a potential for spurious relationships there, and you need to be cognizant of that in designing your analysis, your strategy. The way I do it has been kind of simple, which is that the time series I've showed you are just statewide New Hampshire. And that's a relatively small state in which temperature anomalies are correlated pretty well statewide. The temperatures are higher or lower, but the temperature anomalies, we've run this analysis, First principal component explains about 87% of the variance. So, so we control for it just by only looking at one place. If you go to a national scale, then yeah, you've got Louisiana down here and Maine over there, and they're very different kinds of things, and it is tricky to separate those out.
I was interested in two numbers that you showed. There was the 55% number of people that believed there was a human influence, and then there was the 70% number of people who believed that Arctic ice
Yes.
decline, related to their local weather.
Yeah.
Have you thought about how the two are connected?
Oh, absolutely. And I can tell you more or less, the numbers don't add up like a budget you're balancing, but here's how it works. We asked that question, it has three main choices. Climate's changing mainly to humans, changing mainly natural forces, or it's not changing. Not changing is really unpopular. Nobody says it's not changing anymore. Rather, the issue is causality. Our Arctic weather question does not specify causality. So what you get, basically, in terms of these bar graphs, is you're getting the 53 who think it's, or some fraction of those 53 who think that it's changing due to humans, plus some fraction of the 39 who think it's changing but not due to humans. So when you don't specify causality, more people are prepared to concede that it's changing.
I mean, it's interesting that, scientifically the consensus would be much higher than 55% for the human
Yes.
influence. And for the Arctic sea ice decline affecting, mid-latitude weather, it would be much lower.
Yes.
So it's going in
Yeah.
the opposite sense.
Yeah, well, I mean, that's one of the interesting things about this research, because, of course, we're researching public perceptions, not the scientific realities. And it's informative where they do and do not coincide. Let's see.
It'd be interesting to ask the question on weather to the meteorologists or through the AMS or something like that, because it seems that the public understands that if you have a big change in the Arctic, that ought to spill over into global weather, but it doesn't seem to. The rank and file meteorologists are looking at all the chaos and say there's nothing there. So it'd be interesting maybe to send something to AMS.
Well, I would love to ask exactly these same survey questions at AGU or something like that. Just to get a different sample, because we go different places. We go to Southeast Alaska and do a survey there and ask the same questions. We'll be out in Northeast Oregon this summer asking some of the same questions. So we get place-to-place variation. I've got some colleagues who ask some of them among high school students in northern New Hampshire. If we could get a sample of AGU participants, or AAAS, or AMS, or something like that, that would be fascinating, and it would be a paper, I'm sure. Okay, where's the microphone?
Thanks, Larry. I was just interested in your 53% number that's fairly constant with time. I think that number would be a lot higher in the UK and in other countries around the world. And you kind of implied that it was politically motivated. And I think it's probably increasingly obvious that facts don't change people's minds. And I wonder if you've any thoughts about how we might communicate better, any different ways of communicating. And I just as an aside, I'd like to reiterate this whole blogging aspect. And I run my own blog as well, and I get more people reading what I write there than reading my papers. I've no doubt about it. So I'd just like to highlight that I think blogging is something that's growing in the community, and I think we all need to do more. But yeah, I just wondered how do we communicate? Well,
you raised like 3 good points there, and we're out of time. But first of all, international comparisons. I would love to find international partners who wanted to run similar survey questions with. I don't have the organization to do it in UK or somewhere else, but there must be people who could do that.
There are certainly similar surveys which give higher numbers.
Well, it's useful to use exactly the same questions where you can, especially in English-speaking countries, because the wording can create biases. I've forgotten what your other 2 questions were, but they were good.
So facts don't help, I think.
Oh, what can we do about it? Well, actually, I was running some numbers on the tarmac while our plane was delayed at DIA earlier this weekend, and we've got a new survey coming out that comes with some really interesting, not very encouraging, but interesting results about how you can get people to change their minds. So that'll, if it comes out the way it looked like it did on the tarmac, we'll have about 1,000 new surveys by the end of this week with a new experiment in which we tried changing just a few words and made a 17-point jump. So, okay.
Great. So I'm going to talk a little bit about the data aspects of this and hopefully help kickstart some of the discussions in the breakout sessions tomorrow. So as I mentioned earlier, we kind of separate some of the work on this project into different action teams. And so we have an action team that's just dedicated towards the data side of it. And within that, we kind of have 4 specific objectives that we've listed. The first one is to basically define and assemble and disseminate all the relevant data sets that people need for sea ice forecasting. And ARCIS had already been doing some of that a little bit on their websites to help get people going for the sea ice outlook. And so I'm going to talk a little bit more about some of our objectives and plans regarding that. One of the key things I think that we need to really start focusing on is we need to get guidance, I think, from the predictive models on not just, what are the data that you need and what are the data formats and uncertainties that you can handle in this data, but also some of the best, observation strategies. Where do you actually need to get the data from? What regions, for example, in the Arctic, do you really want the data from to improve your forecasting that you're not already getting right now? Again, within this, I mean, it's always sort of a constant, I think, problem and project is to keep validating remote sensing products and really trying to provide better estimates of measurement error and uncertainties within those data sets. And then finally, we have the 4th goal is to look at developing integrated data sets. And part of this would be to say, try to integrate maybe aircraft campaigns or in situ data with satellite measurements, for example, so how we can increase the information that might help improve forecasting, but also to develop a framework and tools that help standardize some of these observations. And Jenny Hutchings is going to talk a little bit more about that with some of the surface-based ship observations that she's been involved with. So the first thing, obviously, is we need to be able to get people the data that they need for doing sea ice forecasts. And obviously, we do understand from different studies that initial conditions do matter. Of course, it's not everything. Summer weather plays a large role, but obviously, we need to have really good initial state conditions of what's happening with the sea ice. And towards this end right now at NSIDC, we started to put together a new website trying to link together data from anybody that is putting data out there that would be useful in this regards, looking for near real-time data, but also looking at all different types of data sets. And we've broken it down into Arctic-wide data sets, so for people that are running Arctic-wide sort of forecasts, but also regional data sets. A lot of these are based on just what we have out there from different groups in Europe as well as in the US. And I've also made a link more to try to start providing data for general audience. So actually doing what Larry was mentioning, doing sort of, ASCII files, delimited text files with commas, things like that, in order so that the general public can start working with the data easier. So we've also started to produce some general audience data sets for this. So there's a website at NSIDC that you can go to look at this. And obviously one of the things that we understand is that sea ice thickness is very important, and this is a variable that isn't always easy to have, and there's different ways of doing it, and there's different data sets out there that are not necessarily homogeneous. But this is just some work by Ron Lindsay showing how ensemble forecasts using biomass, what the difference is if you actually have the thickness information there versus not having it there, and how you end up with biases in the overall thickness distributions and also the sea ice extent, depending on whether or not you can initialize your forecasting with thickness information. And I think sea ice thickness is obviously one of our key variables that I think we need to be spending some time and focusing on. And I know that IceBridge is underway, and hopefully we'll get the Quick Look product really soon again, like we did last year, that can help set the stage for this year's sea ice outlook. A focus that we're doing, of course, is really trying to, we really want to get near real-time data, because obviously that's what we need even throughout the summer seasons to keep updating our forecasts and doing a better job with our forecasting. But we're also interested in hindcast evaluations of how well the models have done, and we're also interested in sensitivity studies. So one of the things that we did this last year was just get a sample sea ice concentration data set for 2012 daily and monthly fields from 11 different algorithms. And so this was provided to me by Natalia, and we have this data set available through that website. So you could actually run some of your forecast models and test the sensitivity. How sensitive is it to what kind of ice concentration are you actually initializing your model with? So we have that data available. But again, I guess some of our questions, still are, and this is, again, this is how we partner with the modeling community, is really better understanding as to what data are critically needed. And kind of following on that, I know Jenny's going to touch on it a little bit in her talk, but how do we build a network that we can share this data in a timely manner? Because that's really, I think, one of the key things. There's a lot of people collecting data. It's out there, but it's not being shared. It's not in a nice collective network. And I guess that's what we really would like to work towards, is how we can build a good network so that we can all access this data and do our forecasts. As I mentioned, we're interested in obtaining guidance from these different prediction methods on how we can best observe the Arctic. Where should we be doing our sampling? I know Cecilia's done some work on this that she showed at the IGS meeting. And I think we can learn a lot from what the modelers are doing on where we need to be observing, what are the metrics, and how to design our system for maximum optimization of the observations. And maybe we can try to coordinate research flights and industry flights to sort of better observe the Arctic and improve on our abilities to provide the data that we're needing. And part of this, too, of course, is validating remote sensing products. And I put Walt here as a lead because Walt's been really actively involved with a lot of validation of remote sensing products. It's not just validation, because there's a lot of work that's been done on that, but it's really, we want to encourage data providers to start providing measurement errors and uncertainty estimates with their products. I think this is really important. And part of this, of course, is we need to understand what uncertainty level is okay. What can the forecasters, the modelers, statistical approaches, what can they live with the error in the input data? And I know Walt has worked towards developing a sea ice climate data record that is trying to start at least bringing together different sea ice concentration products and trying to give a level of certainty as to, is this ice, is it not ice? And I think more efforts that we can do towards that is really going to help improve our data sets. I think then I'm going to turn it over to Jenny to talk more about integrated data sets.
Standardize a data set so that we actually can have some value added to what's being done already by researchers. So, I'm just take this as an example of where we could potentially go forward with all of our data sets. And I'll point out some problems that we'll come across when we're doing this. So there was a workshop in 2009 where we basically discussed Arctic shipboard collection of observations and a lot of other observations too. But it was really noted that the way that we're collecting visual observations of sea ice are not standardized in the Arctic. We were following conventions from the Antarctic. We needed to make some new conventions that worked for the Arctic. And the journey towards a product where we have software that's available for people to use on ships, a database, and a set of standardized observations is still not complete, but it's about 3 years in development now. And I'm going to talk about how we would use that data with them. These are just some thoughts. Okay, so why would you want to collect visual observations or any kind of observations? Well, if we're interested in forecasting, it's useful to know what the melt ponds are like out there. If you have observations that you can validate your models against that are point measurements, we can use that. So essentially, this is part of a bigger framework. This is one small project in a bigger framework, which is the data network that we're all talking about. So I just threw this slide up here because this is what I think about, which is my very specialized question of how to make a sea ice model that gets the correct drift and dispersion of sea ice. But what I want you to focus on is the fact that there's lots of arrows going into that model, that forecast model, of data connections that need to happen. So how do we formalize this so that essentially we are getting data into our forecast models in a timely manner, and we're getting results out to the people who care? In this case, the stakeholders would be oil industry for this particular project. And there's a lot we can build upon. And when you're thinking in the working groups, maybe it helps to have a picture like this in your head for your own work, because we all have parts of this puzzle that we're already doing. So when it came to the sea ice ship observations, there were some hurdles to overcome. It's like researchers and operational people don't speak the same language. We try to. The sea ice observations are based on WMO standards, but they're not actually identical. So if we wanted to use these observations to put them into an ice chart at an operational center, at a National Ice Center, we had to taught the same language as the National Ice Center is using, which is SIGRID 3 right now. So we've actually taken our product and are converting it into SIGRID 3, which brings up some interesting questions for us as a research community. Now, one of the problems is, how do we characterize sea ice thickness? The WMO nomenclature that we're using is designed for forecasting for ship operations, essentially, or for state conditions in the Arctic. But this is the way we describe sea ice. It doesn't treat thickness in the same way we do. But I do think we need to be involved in this conversation, because we are actually working in the same worlds, and we have the same goals that we're going towards, which is to build an ice analysis that essentially we can use to initialize models. We all want to use the same, be involved with model validation, and we're all going towards forecasting. So there's certain committees and groups that we could be involved with. The ice chart, the International Ice Chart Working Group is where there's discussion on the formalized standard formats for data. The JCOM expert team on sea ice meets every 5 years. That's where they discuss the ice objects catalog, which is part of the nomenclature. I think that as researchers, we should actually be involved with this conversation at some level, but it's really not pure science. So how do we go about doing that? And there's already a lot of ways in place to move data between observationalists and modeling centers. So how do we actually, as a community, monopolize on that and not reinvent the wheel? At the moment, if I think about what I do, I take a lot of sea ice observations from people I know. I'm personally networking. I know where I can find data on the web. But that data then is not necessarily standardized, and it's not necessarily easy to find, and is not necessarily coming to me in the timely manner that we need. So to think of an example of a problem that we need to overcome is for sea ice thickness, and in particular, okay, the SIGRID 3 format and the ice objects catalog talks about sea ice thickness very differently from the way we do. This is an example of a language difference. So you might be familiar with the EGG code there. I just put that there to remind me we're talking about ice analysis here and building ice charts. That doesn't deal with ice thickness in the same way we do. They deal with ice thickness as level ice thickness and the maximum of the mean level ice thickness and the maximum level ice thickness and a ridged ice component. They don't think about the PDF of ice thickness. So we're talking about building an initial field for ice thickness based on many different types of data. How do we combine those together into a standard language? I think this is something the community needs to talk about. So a set of questions that we might think about. Thanks. Sorry.
With some questions, because I mean, really, I think what we want to do is just start getting a discussion going on what is needed. And I think, you know, there have been a lot of efforts, I think, in the past to try to focus on what are the key observations needed. There's been reports written. We don't really want to reinvent that. But obviously, as we learn more about Arctic sea ice and sort of learn more about how well predictions work, we might better understand sort of what observations are still needed that we haven't been doing right, or maybe it's just a regional thing or it's a spatial thing. So we need to look at that. And I think, I mean, obviously one thing that I know Jenny and I are very interested in is, you know, really how do we create this network so that we can have all this data more easily available to everyone who needs it and wants it for their forecast. So, and that's part of what our project is aiming for. I mean, this is a network. I mean, that's a big part of what the sea ice prediction is, a network. So we really want to get thoughts from everybody, especially people involved in data, but also the people involved in doing the forecasts. You know, how can we move forward on this to make things work better than they have been, so that we can actually, you know, improve our sea ice forecast. So I guess I'm just going to leave it open with these questions and take comments from everybody. You guys, questions? Thanks.
I just wanted to maybe add one predictor or predictant, one observable needed for sea ice prediction that we really care about at the Canadian Ice Service is dates or times. So date of ice fracture, date of route clearing, when a ship will be able to pass through a certain passage. So if you look at our seasonal outlook that we produce every summer for the Canadian Arctic Archipelago and the Canadian waters, a lot of it, more than 50% of it, is dates rather than ice thickness or ice concentration.
That's a good point. Sorry.
Thanks. I think there are two issues here. The first issue is regarding coordination between different groups that are doing sea ice observations and research. And the obvious way out here would be just to propose a meeting of all stakeholders. And I think the World Climate Search Program and the CLIC project can offer a platform for this. Because I work at the WMO, I will be able to speak to JCOM people and they will join this meeting. This meeting, I think, is really needed. But the thing also is that sea ice cannot be considered in isolation. For example, the World Climate Search Program is planning certain experiments that involve, of course, climate models. And there are some standards for data presentation that are more global than just sea ice. And Walt Meyer is a member of WSRP Data Advisory Council that thinks about this. So Walt, what do you think about the global requirements that take sea ice prediction research into more kind of Earth system scope?
It's very nice when you get into the Sea Ice Outlook web page. You see everything there. I just wonder if it's possible for the network to set up some kind of a web page that would link all available time-sensitive data set there. That would be very useful and very easy for the modelers to get the data, pull the data off, because the prediction is very time-sensitive. For example, for the ice bridge data that's mostly connected in spring, and we have to wait a few months to get the data, and sometimes we don't really know where we can get the data. So this time gap creates a lot of trouble for modelers.
Mm-hmm. Well, so I guess, that was one of the motivations for putting together this website at NSIDC, was to try to provide sort of a one-shop, one place to stop to get the data that you want. And so obviously, as soon as the IceBridge data becomes available, that will get put on that site as well. And I have it separated right now out for regional as well as Arctic-wide data sets, and I have it separated out by variables. So it's also by sea ice concentration, thickness, timing of the melt, for example, sea ice motions, sea ice age. So we're trying to get, with the data providers that I'm working with directly, trying to get most of these in near real time as much as I can. But they're not all done that way, and obviously they're all being done by different centers, so I can't always make sure that they're going to be updated in near real time. But the focus really has been on trying to push the near real time aspect of the data availability. So we're working towards that, but I think I still wonder though how useful the data is. We link to all the different data sets that are available, but they're all going to be in different formats, and they're going to be at different resolutions. And I just wonder, how does that limit its usefulness for a lot of the people that are doing the forecasting? I've thought about developing some sort of an interactive tool in NSIDC that could take any of those data sets and convert them into whatever format that you would want. This would take some time to do though. And of course, what I would need is better input on what are the data that people really need and want and how they want it delivered to them. But we're trying to work there, so we have a first step with the website.
Yeah, I guess I'll respond to Vladimir's since you put me on the spot. I think it's a good point. There is actually a development going on within the World Data Advisory Council in WCR, but it's actually started at NASA JPL. It's called the OBS for MIPS program, which is observations for model inter comparison processes or something. Anyways, and it's essentially it's really focused on the IPCC CMIP model, but the idea is to get observational data sets and put them into a common framework. And it's not just a format; it's a framework where these can be used universally. And I think that's something to look along those lines. As you said, Julian, it's a tough, it's difficult. But if you just have all these different data sets, then in all different formats, it makes it much harder to actually use those. And so, but I think that's where we'll discuss at this meeting is what does the modeling community and other people need in terms of resolution, formats, uncertainties, and so forth. So I think that's something, and I think that the OBS-for-MIPS is maybe a good thing to kind of model after. It may not be exactly the same, but I think that help. And as Vladimir said, the WDAC and WCRP are looking at this on more global scales, and integrating it within the global efforts would be a good idea as well.
Thanks, Walt. That's a lot of good points. And I guess, one of the things that I was thinking too with this, I mean, we're linking to a lot of different data, but I mean, if we're going to try to work towards that, we might just have to start with some key data sets, some key variables like sea ice concentration or thickness, and just focus our efforts on those to start with, if we know that those are the most important variables that people are going to want from us.
I just wanted to make a suggestion. I mean, we have a lot of the community in the room here right now, and Jenny was talking about workflows and what data sets we use. I mean, it seems like it'd be worthwhile to just make a little questionnaire and have everyone here spend 10 minutes so that you know what the priorities are. I mean, it's one thing to discuss it, but then you don't really hear from everyone and you don't really have the survey of the data that you need. So just a suggestion.
Yeah, that's a good idea. We could probably draft one tonight and circulate it tomorrow. That'd be great.
So uncertainties were just mentioned. We are running a 4D system. So for us, uncertainty is essential. Without any uncertainties, we cannot use any data. So we can handle bad data and not data without uncertainties. So I cannot read any uncertainty here. Is it planned to estimate some uncertainties from all the data sets?
Well, yeah, and I mean, and I'll let Walt comment on that a little bit, because he's been doing work towards that effort with producing a sea ice climate data record for sea ice concentration. Walt, do you want to comment a little bit on that?
Yeah, actually, thanks for giving me the opportunity. I was going to mention that too, but I was babbling on too long already, so and I'll try to make this short. But yeah, there's the NOAA climate data record. We did put an uncertainty parameter in there. It's not a true uncertainty, it's an indicator based on the variability. We're looking at doing that at Goddard with the NASA Team 2 algorithm. It's relatively easy to do. I also mentioned the UMETSAT group. Their sea ice concentration has uncertainties as well. I think there needs to be some effort to actually, these are kind of empirical uncertainties. They're kind of derived based on the methods. We don't know how well they actually correlate with the actual uncertainty. And so I think there needs to be some more work in that, in terms of, if it says that the uncertainty is plus or minus 20%, is it really plus or minus 20%, or is it going to be off by 80%? I think that needs some effort. But I think I agree. In any kind of time you're using data and models and simulation, you really want to know the validity of the observations, and even the outlook. We're comparing to a single number that certainly has a lot of uncertainty around it.
I'm not sure that Alex Jan is in the room, but just to say that 3 years ago we tried to start a list of typically this kind of information that we needed for improving predictions in the Arctic. So typically uncertainties, language, format, and so I can pass the document over to. It's not a full document; it's not complete, but it's a good start, I think. I don't know if Alex is coming to the workshop actually. She was supposed to be here, right? Okay.
So you've talked about using, finding better observations to use to initialize models to make forecasts, and at the same time you're talking about using. Earlier, you were talking about using, models to come up with better observing strategies. I mean, those two things seem kind of incompatible to me. I mean, that was just one comment. But the real point I have in terms of the second bit, where you're going to try to do these experiments with models, to better inform the observational networks that you develop. Do you have any comments, on the various biases that exist in these models that are very profound and would make that exercise difficult? I say that because we did have a new network funded in Canada, and the one part that didn't get funded were those kinds of experiments, because people were, pessimistic that this would ever be achieved.
No, that's a good point, and I guess that's part of the modeling effort, and I think some of the discussions are going to come out here at the workshop about that, and I don't know, Cecilia or Ed, do you want to comment on that part? Because Cecilia's pointing to Ed.
Well, maybe I'll just I'll refer to the session later today. But I think there's Stefan might want to talk. He's over there. I think you can use models in a pretty useful way to build a hierarchy of what your observation needs could be. Of course, there is the issue of trusting the model and that it's a reasonable representation of nature. But yeah, so we'll talk about this tonight or this afternoon. Johnny wants.
So in terms of developing operational forecast systems, to some extent we're stuck with the models that we have at this point in time. So until those models improve dramatically, then they are a sort of a representation of how much predictability we can expect to get from those systems. So understanding what's important in those is quite important now, even if it won't be at some point in the future.
Thank you. Actually, in the polar prediction project that is going to be presented here, there is an ambition to use models to make observing system sensitivity or evaluation experiments. But of course, we all know that polar observing systems are basically opportunity driven. No matter what you derive from models, you will have ships going, and this is what will determine the observations that you'll get in the end.
I think one thing we should take in mind is, or take some cues from the sea surface temperature community, and we really need several levels of data. We need 0 level all the way up to level 4 to the gridded analysis, because I mean, as someone who deals with this, I mean, I'm going to want gridded data for my validation, but when I'm assimilating, I want the raw observations, and it's even possible that you don't want thickness observations, you want what was actually measured, you want the draft measurement or what have you. So it's very important that we do keep all levels of data, and just trying to get some generic thickness observation or something like that is not enough. We need all the information.
Oh, that's a very good point, and I mean, it's not something I think that we've thought about in that kind of detail yet. So to keep all the different levels, because different people might need different parts of that information, and I think that's a really good point to keep in mind.
Yeah, and follow the satellite community's model for that is good.
So in addition to requirements for observations and guidance from the model, that comment earlier, I think that we're getting to the point that models are getting better and better at representing processes and feedbacks within particular component like ocean, or within sea ice, or across different components. We're using coupled climate models to do predictions, and I think that those feedbacks that somehow are or are not properly represented in coupled models need to be validated. So this is a different level of observation requirements, because if a model has a feedback, and reality the feedback is positive and the model is representing in a negative as a negative feedback, there's a problem. But we need to understand the reference and have a reference to fix it. Understanding processes, I know that you can come up with a long list of processes for the Arctic, and everybody has probably their own favorite, but there are some key processes that are critical. And if we identify those processes that the community thinks they are critical, that might be another guidance for observations.
That's a very good point. Oh, I guess lunchtime? Yeah. All right.
Thank you, you guys. Well, it is lunchtime. We have an hour planned for lunch, which I think should be enough to get through the cafeteria. You will kind of swamp the cafeteria when you get there, but they're expecting you. So it's downstairs and towards the right when you get down the stairs, and eventually you're going to make a left, and it's a bit of a maze, but just keep, flowing, and you'll eventually find it. Maybe some NCAR people will take the lead. But yes, do try to come back in an hour. Thank you.